So now in this video here, we're going to talk about simple pendulum. So a simple pendulum, the motion of a simple pendulum, which you are seeing here, is a typical example of what simple harmonic what motion. So I've done a complete video on simple harmonic motion in what my previous video here. So please go check out that video. Just but now let me just talk about simple harmonic motion a little bit here. What is simple harmonic motion? Now, for an object to exhibit simple harmonic motion, there are two things must take note of here. Number one, the acceleration of the object. So an object performing simple harmonic motion. One, the acceleration of the object is directed towards a fixed point or towards the equilibrium point. So if we have the equilibrium point or position, I get. So any object performing simple harmonic motion, the acceleration of the object is only directed towards what a fixed point. That is what number one. Just number two, the acceleration of the object is directly proportional to what, to distance from the point. Just so the acceleration of the object here is directly proportional to the distance of the equilibrium points. Now, what does it mean here? It means that the more the object is moved away from the equilibrium distance here, the more the velocity or the acceleration. Do you understand? Why the less the distance, the less the acceleration. So the more the distance, the more the acceleration. The less distance, the less the acceleration. Do you understand? So these are the two criteria for an object to perform a simple harmonic motion. Do you understand? Now, when you're studying simple harmonic motion, there are three terms you need to pay close attention to. Just I'm going to show you all the formula here because these are the formulas we want solving simple harmonic motion problem here. So the first thing I want to understand is called the amplitude. The amplitude, which is what is the A. Again. So now this is the first thing you want to understand when it comes to simple harmonic motion. What is amplitude? Amplitude is the maximum displacement of objects from its original points. So the maximum displacement of these objects from its equilibrium point is called the amplitude. It's called what? The amplitude. So the maximum displacement of objects when the equilibrium position is called what? Amplitude. It's called what? Amplitude. Do you understand? Now, next one to look at is what is the period. The period, which is T. Now, what is period? Period is the time taken for an object to complete one cycle or one oscillation. The time taken for an object performing simple harmonic motion to complete one cycle or one oscillation. Do you understand? What does it mean here? Now, let me just say here we displace it here, right? Now, if you should leave it, it will move from here down and move here. So the time taken for an object to move from here and backward is called period. The time taken for an object to complete one complete oscillation or cycle. Do you understand? So when you move here is one, move here is a complete cycle. Do you understand? That's called period. The time taken for an object to complete one cycle or oscillation. Do you understand? Now the next one I want to look at is called the frequency, which is F. Now what is frequency? Frequency is the numbers of complete oscillation an object perform in 1 second. The numbers of complete oscillation. The numbers of complete oscillation in 1 second is called frequency. So now that is why the period is measured in seconds. Why frequency is measured in per seconds. Or hertz. This is that. Now there's a formula for period here. Period is equals to what? Which is T equals to what? Time. Time taken over what? Numbers of oscillation. Numbers of what? Oscillation. Oscillation. Do you understand? Period equals to what? Time taken over what? Numbers of what? Of oscillation. Now frequency here. frequency, which is what is f, is equals to what? Frequency, which is f, equals to what? Now, numbers of oscillation, numbers of what? Oscillation over what? Time taking. Do you see that? Now, there's a direct relation between frequency and period. Do you understand? Now, frequency is equal to what? 1 over t. So these are two things to understand when it comes to simple harmonic motion. Do you understand? And these are the very formula you can use. I don't want to go through this one here. You know that you have not watched my complete video on simple harmonic motion. Please go check out that video on simple harmonic motion so that you understand the concept very well. Because I don't want to go deep down here. Do you understand? So these are two things to know when it comes to what simple harmonic motion. Now let's focus our attention on this simple pendulum now. Then we want to move to simple pendulum. Because of simple pendulum, please pay close attention here. There are two things to put in mind here. The period which is what is t, and the length of the pendulum. Length of pendulum. Again, which is what is L. Now, there's one thing to understand here. The more the length, the lesser the time. Do you understand? So, sorry, the more the length of the small pendulum here, the more the time it takes to complete one oscillation. Now, that is why, if you are performing simple harmonic motion here, the larger the length, the slower the speed or the acceleration. But the lesser the length, the higher the speed. Do you understand? If you have conducted simple harmonic motion before, practical, you understand this here. So the longer the length of the simple pendulum, the more time it needs to complete one oscillation. That is why it moves very slow. Move very slow. Now, but the shorter the length, the faster it moves. That is the lesser what time it takes to complete one oscillation. Hope you understand. So now there's an equation for simple pendulum. There's an equation for simple pendulum here. Now you have t equals to what? 2 pi square root of what? L over g. Now look at something here. The period of the simple pendulum is determined by the length of the pendulum. So now you can have pendulum, right? You can have the same pendulum but different lengths. If you have different lengths, you have to have a different period. Do you understand? So you can have L1, you can have L2. So if you have L1, then you have to have T1. If you have L2, you have to have T2. If you have L3, you have to have T3. Do you understand? So that is why you can have a different period with different lengths. If you are using the same simple pendulum in the same location. Now, there's what I want us to do here. So because you can have T1 and L1, you also have T2 and L2, you can have T3 and L3. So what actually determines T1, T3 is L1, L2, and L3. Do you understand? Now, another thing I want us to look at here is because if you look at it here, when it comes to different periods and different lengths here, 2 pi g will remain the same. 2 pi and g will remain the same. So it is said that we can have a constant. We can have a constant. So how do we derive the constant here? Now let's rearrange this equation here. And the first way to rearrange the equation here is take the square of both sides. If you're taking the square of both sides here, to remove the square root here, do you understand? So take the square of both sides. Here we have t square equals to 2 pi all square times L over g all square. Now the main reason why I take the square because I want to remove this one here. So if you look at it here, going to be t square equals to 4 pi square, right? So you have times L over g because this we cancel this in indices. Hope you understand. Now, what I want to do here is this. Here we have t square equals to, right? T square equals to 4 pi square L over g. It's okay. Now let's rearrange this stuff. If we should rearrange this stuff here, let the t be on one side here. You find that here you have t square over what l equals to 4 pi square over g. If you check it very well, do you know the reason why? Because if you what cross multiply like this, here we have t square times g equals to what 4 pi square l. Is it okay? Same here, if you cross multiply, this is what you get. Hope you understand. Now, this one here is what is the constant 4 pi square over g is a fixed constant of the pendulum at a certain length, because it was fixed constant of simple pendulum of what simple what pendulum I there at a what at a what particular what length. So in the sense that this one is always a constant, it does not change no matter how the length and time varies. Do you understand? Now let's apply our T1. If for example now I have T1 and T2, I have T1 and what and T and T2. I'm also going to have L1 and what L2, right? So now let's take again. Now let us take T1 and L1. So here we can say T square 1 over what L what 1. Can you see that? Do you understand? Equals to what 4 pi square over what over g, right? Same thing here. T square T2 square over what L2, right? Equals to what 4 pi square over g. Now this guy equals to this one here, and this equals to this one equals to this. So here we can now see that T1 square over what L1 equals to what T2 square over what L2 equals to what 4 pi square over g. Can you see that? Now this is where things will get interesting more. Now let us focus on these 2 points here. It's okay, let us focus on T1 square over L1 equals to what T2 square over L2. Let us focus on this one here. If you should pay close attention to this one here. Now let us the rest of the constant you can what do straight away or ignore it. Let us focus on this other one here. So here we have T1 square over what L1 equals to what T2 square over what T2 square over what L2, right? Now if you should rearrange this stuff here, this is what you're going to get. If you should rearrange, so you're going to get T1 square over what T1 square over what T2 square equals to what L1 over what L2. Is okay. Now because when you cross multiply, it's okay. When you cross multiply, this is what I'm going to get. If you cross multiply, what will happen here? It's going to be T1 square L2 equals to what T2 square L1, right? Which is also the same to this guy here. Because if you should cross multiply this one here, you're going to get this one, right? So you now have this guy here. Just I'm not have this one here. So this formula I'm going to make use of here. Now we can remember this one is square, this one is square, right? So you can do it like this as T1 over T2 or what square equals to what L1 over L2. Is okay. Like if you want take the square root of take the square root of both sides, we remove some here, you have T1 about T2 equals to what square root of what L1 about L2. Is okay. Now these are the things you want to what make use of in our calculation. So now when it comes to what simple pendulum here, first one is this guy here. It's not equation 1. It's okay. The next you want to look at is what is this guy here. Is this equation 1, equation 2? Is okay. Equation 1, 2. The next you want to look at is what is this guy here, equation 1, 3. It's okay. So we have to solve some common problem now so you understand this one better. So let's take some problem. And look at what this question here. Look at what this question. A small pendulum 0.84 meter long has a period of 0.95 seconds. Calculate the period of similar pendulum 0.46 meter long in the same location. It's very easy. Solution. Now you have a small pendulum 0.84 meter long. That is going to be what by L1 length 1. So going to be L1 equals to what 0.0.0.0.84 meter higher long as a period which what t1 equals to what 1.95 what seconds, right? They calculate the period when the similar pendulum 0 point, so my L2 is equals to what 0.466 meter long. You say you calculate. It's very easy. Just we are using what this one here. So if T1 about T2 equals to, if we have L1 about L2, right? So the goal is to what make T2 the solid formula here. Now what will happen here is that to make T2 the solid formula is very easy. I will assume the whole of this place to be what X. Is okay. So let the whole of this place to be what X. If the whole of this place is X, right? So I'm gonna have T1 over what T2 equals to what X. Now let's make this T2 solid formula here. When you cross multiply, what will happen here? If you should cross multiply, what will happen here? Going to be T2x equals to what T1. Is okay. Now please pay close attention. This is where things get confused here. Now remember I'm making what T2 solid formula here. So divide both sides by what X, right? So we now go x equals out here. So you have T2 equals to what T1 or what X. Is okay. But understand that this one also is saying that what T2 equals to what T1 divided by what X, right? But understand, what is this X? This X is what? Is this. It's okay. This X is this guy here. So you can say, or you can say T2 equals to what? T1 times divide by what? By square root here L1 or what L2. It's okay. Now remember, in in mathematics, if there is divides, right? If I'm going to share it to times, the numerator will go up, the numerator will come down, right? The denominator will go up, numerator will come down, right? So I have to change the sign. So now going to be T2 equals to T1 times square root L2 or what L1. Can you see that? So this is where you now substitute what your value. So you now have what T2 equals to what? My T1 is what is my T1? 1.95. 1.95 times my L2. What is my L2? My L2 is 0.46. 0.46 over what? My L1 is what? 0.84. 0.84. It's okay, as easy as that. So what you want to do is to use your calculator. Square root 0.46 divided by 0.84, right? Times 1.95. So my T2 is what? Is equal to 1.44 seconds. Now, what does it tell you? If my length, if you look at the length very well, if you look at length here, this guy is far higher than this other one here. Just now, because this length is higher than this guy, it requires more seconds to complete one oscillation or one cycle. Do you understand? Now, this guy is less, it will have what less seconds to complete what one cycle. Remember that the higher the length, the less time it takes to complete what cycle. So that is why you see when you are conducting simple harmonic motion like small pendulum, so that as the length gets shorter, it moves faster. Do you understand? So the shorter the length, the less time it takes to complete what one oscillation. Now we have to start this class here. There will be a part two of this one simple pendulum where I want to solve more problems. Just that if you're not subscribed to this YouTube channel here, can you subscribe to this YouTube channel? Because if you don't, you may not see this channel again and you miss out every single thing I'm uploading on this YouTube channel. Just my goal is to make sure that you pass your JAM examination very well. So you want to subscribe to this YouTube channel here. Hit the notification bell icon so that whenever I upload a video, you understand, you'll be sending what in notification. Another thing here is that I want to tell you that we have class here every sorry. Now, what I want to understand here, we have class here every Saturday and a Sunday, just by 9 p.m. to 11 p.m. every Saturday and a Sunday. So that's why I want to subscribe to this YouTube channel. Just if this video is helpful, please give it a like and subscribe to this channel. Thanks. See you in my next video.